Hello everyone, and welcome to Jumper Man Tech, where we specialize in HVAC but do everything DIY. And today we are 23 stories high and we have a service call for a water-cooled heat pump. Thank you to everyone tuning in to Jumper Man Tech. We have a service call for a water-cooled heat pump. It's 83 degrees in the room, set to 68, and this unit is actually in the wall. Oh, apparently it's okay. Alright, the filter is a bit dirty for sure, but it ain't the worst. Also, if we look inside here, you can see we have a red blinking light. That red blinking light is going to indicate a problem. This is an Omega heat pump. If you guys heard of Omega heat pumps, drop a comment below. Honestly, they're not well known, and ordering their parts through their distributor it's absolutely horrendous. All right, so I just took off this little panel here. We can get to the controls, and as you can see, a red flashing light, and underneath that it says LPS. So we have here a low pressure sensor issue. Interesting. Let's turn off the power. Let's take off this panel here and let's do some tests. One thing I can tell you right off the bat, a dirty air filter can cause a restriction in your evaporator coil and airflow, where the system could trip on low pressure. So you always want to keep your filters clean, man. Off the screws holding this panel. Let's see what's going on. Let me put some of this here for now, away from the wall. When you come into residential, you should cover your shoes and you should cover the floor with a drop cloth. That is the professional way to do it. Dry. Their condensate pan is dry, so what I'm gonna do is actually pull this out. All right, pull it out enough to where I can at least maybe get my gauges in there. So let's see, there's a couple 1/4-inch screws here, and like that I will be able to see what's going on there. And of course we got some missing screws. I'm gonna use my little stubby multi by Klein to get rid of those tools. Might need to take off the water hoses to take off this cover, but let's see. Oh no, not with this one. This is gonna come out. But came off with the insulation from the cover. Let's see what's going on, guys. You thought I work in some nightmares? Over here we got some real nightmares. All right, let's see. First things first. Yep. All right, guys. I already did a few of these, and I'm finding a similar problem in multiple apartments. So Christian went downstairs to get my batteries. I left them in the truck. So let's see. High pressure control we have up here with the 2 blue wires coming out and black and white from the board. I'm looking at it, and it is correct. It's set for 600-pound cutout, and this is refrigerant 410A. I have found other high pressure controls set to cut out at 350, where the control was replaced, but it was replaced with the wrong pressure control. It's supposed to cut out at 600. That's normal for 410A. 350, that's more like a refrigerant 22 type of deal. So they got the wrong pressure controls in there, or there are no pressure controls at all. And if you look here, just because I have experience with these already, I only started working in this building maybe a month ago. If you look right here, we got a car fuse. Right there, car fuse. Basically, the low pressure controls jumped out and it still trips. I called Omega themselves to talk with tech support, and they said if they don't have a low pressure control in there, the board eventually will sense it and shut it down. So this is your low pressure control. A car fuse. Got my walking light. So let's see what we got in here. We do have an actuator for water, and if you can see, we have water lines with 2 water houses. So supply and return. If we look closer, right here, that is our high pressure control right here, and our low pressure control is back here. You see right here? Yeah, right there. It is disconnected, and this is what you have for low pressure. They basically jumped it out with a car fuse. So let's get the digital gauges on there, push this back, put the cover in with the dirty filter and see what shut this down. I really don't know what is special about those kind of pressure controls. If from the manufacturer, they seem so generic. I can see this one was actually replaced as well. So if that's okay, maybe they just need pressure controls. I have generic ones in the truck. The building manager wants to try those, and those are a lot less expensive, rather than calling calling Omega and going through their distributor and getting their OEM parts. They cannot comment on that. Of course, they want you to buy from them. This is a very, very basic pressure switch, probably the most basic on the market, and you kind of see them everywhere. I doubt they invested money for there to be something special inside there. It's just a switch. There's like almost no resistance. So I don't see how that would work, but I guess they said that, listen, even over time, if there's no low pressure control connected, it can still sense that there's a problem. So I guess let's see what they say. We might put in a generic and see how it goes as a test. I would put the OEM just because that's what tech support said, but if they want to go the cheaper route, we can go the cheaper route, but that comes with a risk. All right, guys, I connected the digital probes. This refrigerant 410A. This is our standing pressure, about 232 pounds. At the moment, it seems good. Let's give it a few minutes. I cycled the main power switch off. You can see we all have green lights, and now we're on a timer. We are set to cooling. It's 83 inside. It's set at 68. Fan on. You know what? Let's put the fan on auto. Fan on auto. And system on auto. Cool. All right. So let's give it a few minutes and let's check these pressures. I also have temperature probes, but I can barely fit it in there. Those hoses really get in the way, even for those tiny probes for pressure. So let's give this a few minutes and let's see if we have a low pressure condition or the board is just sensing that there's no low pressure control in the system. Compressor started. We have a 131 pound back pressure, 297 to 98 pound head pressure. And honestly, these pressures are totally fine. The suction seems a bit high, but then again, it's 83 degrees in here. We have a supply temperature. I don't know if you guys can see it, but it's 61 degrees. So we have a 22 degree difference of the space temperature with the supply air, and it's going down 60.6. As the space temperature in here drops, so will our supply temperature. And this is even with, you know, the slightly dirty air filter. These pressures seem normal, but let's let this run for a little bit. The conditions seem fine. In my opinion, what's going on is that it just senses that the low pressure control is missing. Last guy put a car fuse in there, and you guys won't believe it. I found one apartment where they tripped on low pressure. I looked at the low pressure. There was no low pressure control. Instead, he put a washing machine part. It was unbelievable, and it was senses temperature. So a temperature sensor for a washing machine instead of pressure, and he put it in a compartment where there's a compressor, and it trips at 80 degrees. And you know that compressor is real hot, so it still tripped. Anyways, all right, we dropped a degree. What we got here? 59.7, so it's just gonna get better and better. Let's watch these pressures, but these pressures honestly seem normal. It sounds like they need a low pressure control in my opinion. Turned off the thermostat, turned off the main power here. Let's just pull this out a little bit. Okay. You know what? I might be able to do it through here, or I gotta take off the whole thing. But right now, let's take off these probes. You wanna use these so you don't lose the refrigerant in there. Anyways, let's take that off. And what I'm thinking of doing is putting a swivel T inside where the low pressure is, right here. Because the other side, if I pull that out, you don't know if there's a pin inside there, a Schrader valve. If there's no Schrader valve, this thing is gonna leak, man. So, I have no idea. I would test it with the one downstairs, if anything. And if so, maybe I could put the pressure control in its place. If not, swivel T, so we could put the pressure control on and also have a port to check low pressure. This here is a swivel T, and this is probably as short as we can get. So hopefully we can still put the cover back on. It comes with one Schrader valve and the other side with no Schrader valve. So I installed a Schrader valve. Basically I used the other end of this cap and just spun this on. So that's gonna be safe. So we're gonna bring that in. Let me get the small adjustable. If anything, let me get the baby one, the 4-inch red one. So basically we're gonna just put this on the low pressure port. So now we can attach a low pressure control on one side and then still have a port to read pressure. Let me get that. And let's see if this is the right size to tighten this. Oh wow, it's not. Let me get the next size up.
Right.
Yep, next size up. So we're gonna put that on. And also you're gonna wanna make sure this thing doesn't leak. Also check to see if there's a depressor. Inside here there is a depressor. I'll take a picture so you guys can see the little, at the end there's like a little pin thing. Basically it presses down on that Schrader valve, and now we can read pressure on both sides. All right. Another thing, here's our low pressure control. You want the right pressures for the correct gas. Also, you gotta look inside here and make sure this has a depressor as well. So you gotta know if it needs it or it doesn't. We're gonna connect the new pressure control made by Subco onto our swivel T. For the threads, I'm gonna use gasket and thread sealant by Nylite Blue. And this is compatible with all refrigerants. You don't wanna use just anything for that. And this is gonna create a nice seal in between the gasket and our swivel T. So this will help prevent leaks. I use this on like flare nuts and basically any connections with refrigerant using a thread. Let's open this up. Let's put some of this, let's get that to the bottom. Let's put some around the thread. Okay. Go all the way around. Make it, basically we're making a gasket. So we have a nice seal here for our threads. As you know, threads can leak. For water, people use like Teflon tape and some kind of sealant. So we're gonna do that. And then I'm gonna spin this on. Right there. Gonna spin that on. And then get a wrench on one side. And maybe here. And like that, I'm gonna make a nice seal. And that should do it as far as that. And then we're gonna use that over there. If anything, what would be nice is to even put some around the thread in there and have this done like that, and that should help with any leaks. Yep. All right, hold up. All right, I'm gonna do the same on here. This stuff honestly helps a lot. Gives you a little confidence booster that there's gonna be no leaks, but we will check for leaks afterwards as well. We will be doing a leak check, and we know that we have 200 pounds of pressure in there. It's just standing. I'm gonna wanna check that when it's off, because this is the low side, and as you've seen, the low side pressure is lower when it's running. So almost by half. So let's just get this all around there. All right, get a nice seal there. And then we can put on our swivel T. All right. And tighten everything up. Let's see if I can get my camera in here. Tightened it with a wrench. And right there, you can see there's, you can hear that there's no leaks. Let's go ahead and test that and put the wires together for our low pressure control instead of this fuse, which is just absolutely ridiculous. We're gonna use a liquid leak check solution. Others call it a soap and bubble test, and this is the Big Blue Sub-Zero. So we're just gonna spray that on the connections that we made. Check for any leaks. Right here, right there. Let's run our finger through it. All around. Sometimes you want to put your finger around so you can see the bubbles. But honestly, we're probably going to be alright. Let's keep an eye on this. Let's see what's going on. It's looking good right now. Let's strip these wires back. I let the system run, not run, but I left the leak check on the system to make sure that's okay and everything looks good. Let's get this. Let's get these wires off this fuse and put these wires together and tie knot everything. Wire knot everything, excuse me. Just wire knot these. And just neaten up the wires to make it safe. That's pretty much what we're gonna do. Like long connections at first, and then I cut it. Okay, then I cut it so I know I have a nice connection when I put the wire nut. If it's too long, the wire nut's not gonna fit. And then we'll use the tie wrap to neaten up the wire. All right, got our low pressure control. Tie that in there to make sure it's not hitting any of the, you know, like a discharge line or something like that, because that will burn out. Anyways, there's the control, and we can also test pressure. That's why we put in the swivel T, because if not, you're not going to have any test ports. Let's put some caps on this and reset this unit. Pressures look good. Got the cover back up. Got the little grommets here on both sides, so it doesn't have any rub outs on the water pipes. Screws are back in, and the insulation's back inside. We should be ready to slide this back in. I had the next unit running, and basically the whole time we were doing that repair, this thing has been running. It's been running for a while. So first things first, we have a high pressure control here. If we look at the numbers, E119117 by Mars, I can tell you right now, that's the wrong pressure control. Like I was telling you guys, it should be at 600. This thing is actually a 300 PSI, 350 PSI cutout. I'll show you a picture. Also, as far as low pressure, where is our low pressure control? All the way back here. It's facing like down. And as you can see, where'd that go? Right there. Come on. Another bypass control with a car fuse. Jeez, man. Last time it was 25 amps, this time 30. This unit doesn't have a problem, but eventually it will. And it's gonna cut out just like the other one. And it looks like in this case, they need high pressure and low pressure controls. What a beautiful day. Real quick, if you can see, we have a standing pressure of 190 on this system. Low pressure control bypassed. That is not a fix, my friends. That is not a fix. This thing is gonna ice up. And even with that bypass, this thing still shuts down on low pressure control. And we got the wrong high pressure control. Unbelievable. This is a 5-year-old building. 5-year-old high rise. Look at this place. These people pay a ridiculous amount of rent. I got a call, but anyways, real quick, I changed the filter on this one, and we put a new filter on the one we just worked, and we're gonna be all right. All right, guys, you know what? Maybe the standing pressure wasn't as high because it is colder in this room, and I had it running for a while, so it probably takes some time to equalize. But 126.5 low pressure, 302.6 high pressure, I'd say this is okay considering it's colder in this room. So it kind of matches up with the other one. They're gonna need low pressure and high pressure controls. Here's the unit that we just worked on. As we found it at 83 degrees, you can see we already dropped 5 degrees in here. And out of courtesy, we also replaced their air filter. So that's that. We're gonna wrap this one up here. If anyone found this video interesting or helpful, please drop a like, comment, and subscribe as I come out with new videos every week. And I'll catch you all next time.